Our force balance problem is basically just a seesaw. We can have a heavy weight on the right and a light weight on the left. These can be balanced if we just adjust the distance accordingly. And we adjust this distance according to the formula, our L1F equals our L2F2. So we can get this balance achieved just by adjusting the distance, which is basically what we're doing. And we'll need to consider this as two separate seesaws, if you will, the left-hand seesaw and the right-hand seesaw. They're related, but they're two separate seesaws. We have our process coming in here on the left, which pushes on our bar, and then that creates a force going in the opposite direction. Because this seesaw on the left is connected to the seesaw on the right, because it's connected to the seesaw on the left, our seesaw on the right also has a force at this particular location because of the bar, this bar, to go to the right. So let's label a few things. We're going to call this F1 because it's what happens first. We're going to call this one F2. And then we're going to call this one F3, but he is going to be the exact same as F2. And then we'll call this guy F4. We'll need our formula. Our formula is L1 F1 equals L2 F2. So let's see what information we were given. Our information tells us that we have process going in at, and I believe he said this in class, it was going in at 10 psi. That is not a force. That's actually a pressure, which is nice because we can get the force from this pressure, but it's not the force that I put into this formula. So what I need now is a pressure-force relationship. I know that pressure equals force divided by area. So that's nice because now I have 10 psi, pounds, we'll write pounds per square inch, equals F divided by the area. Well, he didn't give us the area, but he did tell us that the diameter of this particular diaphragm was 3 inches. So if I have an area formula, I can get the area, I can plop it in right here, and then I'll be able to find my force, my F1. So my area, I have a couple of choices for area. I can do area equals pi r squared. And they didn't give me radius. That's my favorite one to remember. It's easier. But I can still do it with diameter if you want to, or I could just do the radius. The radius of this would be 1.5 inches. But you could also do pi times, now the radius is the diameter divided by 2, so that's where we get the formula pi d squared over 4. I don't care which way you do it. What we're going to end up with is area equals 3.14, and I'm just going to say times 1.5 squared because that's my favorite formula. And with this I get, after crunching it in the calculator, 7.068 inches squared. So I almost have my force. This is 7.068 inches squared. Next, what I need to do is solve this equation. So what I'm going to do is I'm going to multiply both sides of this thing by my 7.068. Alright, and so I'm multiplying both sides by that 7.068. This cancels, and it yields force when I multiply the 7.068 times the 10 with the inches squared canceling. would be 70.68 pounds, which is what I wanted, and that is now F1. Alright, so now I got rid of all that stuff. I'm ready to plug some things in. Let's look. This is our side 1 right here of our seesaw, side 1. This is side 2 of our seesaw, and we're going to deal with one seesaw at a time. So length 1 on side 1, that would be 1 inch times, my force was 70.68 pounds, and that's supposed to equal side 2, which is 2.5 inches, times F2. And now I'm going to solve this equation by dividing both sides by 2.5 inches. Those guys cancel, my inches cancel, and I'm going to get, for F2, after punching this in the calculator, you'll get 28.27 pounds. Now I go on to the next side of the seesaw. Alright, for my next side of the seesaw, I'm going to be looking at L3. F3 equals L4, F4. And I know that F2 and F3 are the same, so that makes it nice. So this is going to be side 3, and this is side 4 of my completely separate seesaw. So the length of side 3 is 0.25 inches, and my force is what I calculated for F2, that's 28.27 pounds. And L4, I know that would be 1.25 inches times F4. Going to solve this equation, dividing both sides by 1.25 inches, and have canceling here, inches cancel here, and I get that F4 equals 5.65 pounds. Am I done? Oh no, because he doesn't want the force that comes out of here. He wants, what's the PSI? So he wants the pressure. And I know that pressure equals force divided by area. Well, I've got, so this is the pressure coming out of 4, because I'm going to be using force 4, so I'll need the area that's associated with this side 4 of my seesaw. And my force, that was what I just found, 5.65 pounds, divided by the area. He gave it to me. I don't have to calculate area in this case, so that's nice, 1.25 inches squared. So when I crunch these numbers, I get 4.52 pounds per square inch, or PSI. Now, if you are wanting to go backwards, which if he wants you to do it from 3 to 15, so if he wants you to do backwards, what you'll do is you'll plug the 3 in for pressure, you'll go get F. Once you have F, your F4, then you plug it into this formula once again, and you'll get F3. Once you have F3, then you'll say, well, that's the same as F2, and then you can calculate F1 from that. And after you get that, then you can calculate what the pressure was on force 1 by using the area.